In this chapter, we will be studying topics in trigonometry. In this lesson, we'll be introducing the basic ideas for right-angled trigonometry.
All right, hi everybody. So we're going to start a chapter here on trigonometry. And I'm going to admit, trigonometry is one of my favorites. It just works together so beautifully. It's just an amazing example of what we can do with mathematics and how all of the little pieces fit together. There's a lot of little pieces, but they all fit together so nicely, like cogs in a machine here. Now, when we talk about trigonometry, we were talking about really analyzing triangles, okay? Getting information out of triangles and using that information to find things that we don't know about the triangle. Now, you've very likely already bumped into the Pythagorean theorem, and everyone kind of says here it's a squared plus b squared equals c squared. Now, that's true so long as your right-angled triangle here is labeled A, B, C. Doesn't always have to be labeled that way, though, and we're going to talk about that just in a second here. It's probably better to think of it as it's the one leg of a triangle squared plus the second leg of the triangle squared, and that's going to equal the hypotenuse squared, right? Because remember, these two lines here, the two sides of the right triangle that make up the right angle, those are called the legs of the triangle. Anyway, there are two ways that we typically use the Pythagorean theorem. Let's just take a look at an example of each here. Now, you probably can't even see the sides here. But this is the length 4 and this is length 6. And we're going to use that to figure out what the hypotenuse is. And that's pretty straightforward. We know that that's going to end up being 4 squared plus 6 squared is equal to c squared. And 4 squared is going to be 16 and c squared, or sorry, 6 squared is 36. And when you put those together, you're going to get 52. Right? And we know that the next step here is to take the square root. Now, normally when you take the square root of both sides here, you're going to end up with a plus or minus result. But we know that we're talking about the side length of a triangle here. So we know that it's going to have to be the positive one. And when we go to our calculator, we'll get that this is going to be approximately 7.2. Okay, whatever units they're giving us here. Oh, and I can see by the screen here, that's not entirely clear. Let me write that out again. So it's going to be 7.2. Or roughly. Okay. Now, this is one way to use the Pythagorean theorem, where you're giving two sides, the two legs of the triangle, and asked to find the hypotenuse. Or, and this is really the only other problem you can get here, what if I give you the hypotenuse? What if you know here that this is 12, and that this leg here is 8, and we're trying to find another leg? And this is a y here. Well, then we know that the relationship here is going to be 8 squared plus y squared is equal to 12 squared. Very, very common mistake, and a very predictable mistake, mind you, as well. And I want you to think about that because when your teachers put together the multiple choice portion of your exam, if you've got that in there, this is a mistake that we can anticipate people making here. A lot of times people will just see the two numbers here and automatically plug it in as 12 squared plus 8 squared equals and figure out the other side here. They forget here that actually what you got to do, this is going to be 64 plus y squared equals 144. What they forget to do is to subtract the 64 from both sides. Okay, so I gotta, instead of adding the two together, I actually gotta take the leg and subtract it from the hypotenuse squared. And when you do that, kind of the 4's will cancel here to 14 minus 6, we're gonna get 80. And then once again, we take the square root of what's left over there, and we know it's going to be the positive square root, so to the nearest tenth, that's going to be 8.9. Okay, and those are the two different ways that you're probably going to end up using the Pythagorean theorem. Okay, the Pythagorean theorem is going to show up. Okay, guaranteed. At some point in this chapter here, you're going to use the Pythagorean theorem, probably a bunch of times here. Now let's just make sure that everybody is okay with how we're going to label the triangle. So basic trigonometry involves ratios of the sides of the triangles. It's important to be able to label a triangle. Now there's really two types of labeling that we're going to use here. But to start off with, first of all, we're going to label the vertices here of a triangle. And it says it right here, triangle MNP, and we usually use capital letters, okay, capitals for the vertices. And then we use lowercase for the sides. But there's a rule for how we do that. So here I've got my triangle M and P. We're always looking at the opposite side of the triangle. So if you want to think about it like this, here's vertex M. The angle here is made up of these two sides. So the side that we're going to label M will be the one that's not making up that angle. So put little m over here, just like here's P, here are the two sides that make up angle P. So it's the side opposite that we're going to label little p. Here's N, here are the two sides making up N, so we're going to label the side opposite little n. Okay? And the reason we do that is because it's very easy to make that jump there, to see the connection between this angle and this side. It would actually get quite confusing if some people said, well, no, let's do the one that's like on the clockwise rotation. Well, then why not use the one that's on the counterclockwise rotation? Why don't I not use this side? Why don't I use this side here for N? If we all agree that's just going to be the opposite side, it's really easy to identify that, and it just makes more sense. Additionally, the larger this angle is, the larger this size is. So there's a nice relationship between that angle and that side, right? The smaller that angle is, the smaller this opposite side is. So there is a nice built-in relationship there that we're kind of making use of here when we do our labeling. Now, but there is another way that we label the triangle when we start talking about trigonometry, okay? Particularly with right angle triangles. Now, it's important for you to know, okay, if this is your introduction into trigonometry, that when we do trigonometry, when we talk about trigonometry, our focal point here is on the angle. Okay, we are going to focus our attention on an angle in the triangle, not the right angle triangle, not the right angle here. Okay, I need the triangle to be a right angle triangle for what I'm about to do to work. But what I do is I pick one of the other two angles. In this case, we're going to use this one down here. This is called theta. Okay, we're going to use the Greek letter theta to refer to the angle that we don't know. So here's what happens in trigonometry. Either you're going to be given an angle, and that is going to determine how you label the triangle, or you're going to be asked for an angle. And again, that will determine how you label the triangle. And when I talk about labels in this case, I'm not talking about the kind of the lowercase letters here. What I'm talking about is this. In your triangle here, the hypotenuse is the hypotenuse. It's the side that's opposite. Now, here, maybe we should zoom in on that. The hypotenuse is the side that's opposite the right angle here. Okay? I think most people kind of get comfortable with that, especially if you've done the Pythagorean theorem. You get comfortable with what the hypotenuse is. If you're looking at this angle right here, then this side of the triangle over here, this is the opposite side. That's going to be little a here. That's going to be the opposite side to that angle. But this other leg here, this is going to be the adjacent leg. Now, whether a leg is opposite or adjacent, and remember that adjacent means right next to, it's right up against, okay? Like your neighbor's house is the house that's adjacent to your house. The way we label these are going to be, first of all, dependent on which angle you chose. So just so that you see this, if I was to have done this, kind of roughly the same triangle, this is still going to become the hypotenuse. I really can't change that. But if I had chose this to be my angle theta, then this side over here, this is the opposite. And this side here is the adjacent. Okay? So remember, when we do trigonometry, you're going to pick an angle, one of the angles, and that's going to be the one that's of primary importance to you. And that's going to determine what sides I call the opposite and adjacent. The hypotenuse will always be the hypotenuse. Now, here's what we do, with that information. We're going to build ratios, okay? Now, in another video, I've gone into this in a little bit more detail and kind of built up this idea a little bit more. But for right now, we just want to kind of jump right in, okay? Kind of like swimming. You just got to jump in and start doing it here. So what I'm going to do here is I'm going to define some ratios here. We define the sine ratio of an angle. And this is going to be the sine ratio for an angle. This will be the cosine ratio we call for an angle. This will be the tan ratio for an angle. Oops, I forgot the n in the middle here. Oh well. Anyway, because you always need to refer to an angle here. So when I look at this angle right here, and I ask for the sine ratio, what that's going to be is it's going to be the length of the opposite side divided by the length of the hypotenuse. Now, because I'm not going into a lot of detail on kind of the foundations of this branch of mathematics, we're not really going into a lot of detail to explain why this all works. What I want you to do is you got to kind of trust me here that no matter how big the triangle is, if this angle is, let's say, 30 degrees, then the ratio that you build here, the length of the opposite side, if you divide it by the hypotenuse, it'll always be the same ratio. Okay? That's one of the really, really neat things about these triangles here. If you make a really, really small triangle, okay, if I was to draw a really, really small triangle with the same angles, the same size of angles in here, the ratio of the opposite side divided by the hypotenuse would be the same for that little triangle as it is for the big one. It's always the same. But it always depends on the angle. Because remember what we were saying up here, okay, or over here I should say, the size of this angle determines really the size of this side. And that's what's influencing the value of the ratio. For the cosine of an angle, what we get here is it's the length of the adjacent side compared to the hypotenuse, or the adjacent side over the hypotenuse. That's what the ratio is that we're getting. And then the tangent ratio is the ratio of the length of the opposite side divided by the adjacent side. So those are your three primary trig ratios. Okay, just to go through this again. So the sine ratio of an angle, so you focus your attention on this angle, is going to be the length of the opposite side divided by the hypotenuse when you draw a triangle with that angle. The cosine of that angle, okay, is going to be the length of the adjacent side divided by the hypotenuse. And again, for any angle that you plug in there, it's going to be the same ratio regardless of how big the triangle is. And that's the amazing thing. Okay, so if I know that angle, I have an idea of what's going on between those two sides here. And with the tangent, it's going to be the length of the opposite side divided by the length of the adjacent side. And so what you'll see here is you'll see people short it down to OH, AH, OA for sine, cos, and tan. And then one way to memorize this is to do this SOH, CAH, TOA, SOHCAHTOA. Okay, SOHCAHTOA. Just to help you memorize those, because you're going to likely need to have those relationships memorized. Okay, and then there it is, SOHCAHTOA. So just a little bit more information about how that works here. So what I want to do here is, for this little question right here, what we're going to do is we're going to take a look at this triangle, and we're going to identify the sine, cos, and tan ratios based on this triangle right here, okay? Now, the question here says, for the triangle ABC, label triangle based on angle A, and then determine the three trigonometric ratios here. So we are focusing our attention on angle A. So this is going to essentially be our theta. Now, once you've done that, okay, remember what that means. I'll try to zoom in here. This now helps me identify how we label the sides of the triangle. Now, this is still the hypotenuse. Okay, because it's opposite the right angle here. But if this is the angle that I'm interested in, then this side over here, which would be labeled little a, okay, is going to be the opposite side. And this side right here, okay, which would be labeled little b here, this is going to be the adjacent side. And it's adjacent to the angle that we're interested in here. So now let's slide over here. We're supposed to come up with the sine ratio. Well, sine is opposite over hypotenuse. Let's go over here. The opposite side is 6.3. The adjacent side is 10.2. So 6.3 over 10.2. 6.3, I'm just going to go to my calculator here, divided by 10.2. Okay, and to the nearest thousandth, this is approximately 0.618. So that's the ratio. Now at this point, I still don't know what that angle is, but I know that this is the ratio that is linked to that angle. Whatever that angle is, it's a unique angle. This is its sine function, and that's the only value that goes with that angle. Okay, they're linked together. Cosine is going to be the adjacent over the hypotenuse. So let's go to my triangle here. My adjacent side is 8.2, and again, my hypotenuse is 10.2. So this is going to be 8.2 divided by 10.2. And again, I'm just going to go over here to my calculator and plug that in. And to the nearest thousandth, that will be 0.804. Okay, and again, whatever that angle theta is, that is the unique ratio that goes along with the cosine of that angle. Now remember, these are the same angles, by the way, that I'm working with. The sine ratio and the cosine ratio, they will be different because we're pairing up two different sides. If we look at the tangent ratio, that's going to be the opposite. Whoops. Oh, I don't know why I felt obliged to put a theta there. Let's get rid of that. This is going to be the opposite over the adjacent. And when I look back, my opposite is 6.3 and my adjacent is 8.2. And so now, when I go to my calculator, 6.3 divided by 8.2, I am getting approximately 0.768. So these are the three trigonometric ratios that go along with this angle theta, whatever that angle is. Now it turns out somebody has gone through and done a lot of work and figured out how we can link these numbers to the angle, and there is a way of doing that. It's actually on your calculator. So what I'm going to do now is I'm going to run you through some examples of how trigonometry gets used once you're looking at a triangle and you get asked to use it to find different parts of the triangle. Okay, so here we go. We're going to show you how to use trigonometry to find a side of the triangle and then the angle of the triangle. Okay, and I'll show you how everything's on your calculator, so that's all you got to really worry about here. Now, before we do anything here, and you've got a bunch of little blah 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 up here to kind of tell you what I'm going to do here, but it makes way more sense just to jump in and show you how to work it. The one thing I will draw your attention to is your calculator should be in degree mode at this point to do these questions. There are a few different modes your calculator can be in, at least a couple. For most calculators, there's at least two that your calculator can be in with respect to angles. We want it to be in degrees. Okay, so now I'm going to work through a few questions here. So I'm going to find side x here. Now, this question has already focused my attention on the angle 36 degrees. Okay, so there's my 36 right here. So this is the angle that's significant to me. This helps me label the sides here. Now I already know this 60 right here, and I'll maybe write that a little bit bigger. 60 right there. That's my hypotenuse. Oh yeah, and you can hardly see that. That's 36 degrees. This makes this my opposite side. So that's the thing I'm looking for. I am looking for the opposite side, and I know what the hypotenuse is. So I've got these two sides to work with. Well, wait a minute. I know that every angle has a unique ratio of the opposite to the hypotenuse, and that's the sine of that angle. So I know that the sine of 36 degrees is going to be equal the opposite length, that x that I don't know, over 60, the hypotenuse. Opposite over hypotenuse. Now, all that I would need here is I simply need to know what is the sine of 36 degrees. But fortunately for me, that is in my calculator. Whoops. Right here. There's my sine button. So I would press the sine, okay, of 36. And when I do that, close the brackets, there's the ratio right there that I'm looking for. Okay? 0.587, I'm going to go to 4 decimal places here, so 0.5878 when I write it down. So 0.5878, and that's going to equal x divided by 60. Now, there's that ratio, and I'm leaving it on my calculator. I'm going to go back to my calculator in just a second here. Now, for me to get x here, what I'm going to do here is I'm going to write this decimal as if it's over 1. And hopefully, as soon as I did that, a lot of you saw what, or can kind of predict what I'm about to do here. If I want to get x, I'm going to cross multiply. I know some people don't like calling it cross multiplication, but I think it illustrates quite clearly what we're doing. I'm going to multiply 1 by x, and then I'm going to multiply 60 by that 0.5878. Except what I'm going to do here is I'm actually going to use the ratio that's right here. I'm just going to press multiply by 60, and I'm going to get 35 point, when I round that 3, 35.3. And so there it is. That is the length of the opposite side of that triangle. Because the calculator knows what that ratio should be. So I'm going to only have one part of that ratio, and I can cross multiply to get the part that I'm missing. That's how that works here. So let's take a look at another one here. So here, the angle that I'm working with here, and I'll rewrite this, is 25 degrees. And the side right here is 8. But this becomes my primary focus. That's the angle. So I look, you can see what's going on here. They want me to find side B. That's the opposite side. But in this case here, I don't know the hypotenuse, but what I do know is the adjacent side. So now I got to think, what trig ratio do I know that links together the opposite and the adjacent sides? Well, that's tangent. Okay, that's what we call tangent. So the tangent of 25 degrees is going to equal the opposite, that's little b, over the size of the adjacent, that's 8. So if I know what this is, if I could figure this out, then I would have that unique ratio that I can compare to this one. And once again, the calculator does, because there's my tan button. So the tangent of 25 degrees, 25 degrees, press enter, and I'm going to get 0.4663. Okay, 0.4663, it'll equal B, sorry, I read my own writing wrong there. That's supposed to be a B over 8. Well, again, I'm going to put this over 1, and I'm going to cross multiply it. I'm going to get that B is equal to 8, okay, multiplied by 0.4663. That's what I write down, but on my calculator, I'm going to leave that in there. I'm just going to multiply that by 8 to get 3.7 when I round it to the nearest tenth. So B is equal to 3.7 meters. Now I know what the units are, so I can write that. Let's do one more here. So in this triangle here, it's the K that I don't know, the hypotenuse. I'm given that this is 53 degrees, and I don't know if that's really abundantly clear, but let's just say this is 53 degrees right there. And I know that the adjacent side, because if this is the angle that I'm given, I know that this is going to be adjacent, and I know that that's 45. So I know the adjacent, I don't know the hypotenuse, but the fact that I'm kind of putting those two together, that I've got that information, that suggests that this is the cosine ratio of that angle. So the cosine of 53 degrees is going to equal the adjacent 45 over K. So if I only know, if I could just figure out what the cosine of 53 degrees is, what that ratio should be, I can do this. Well, fortunately, there's your cos button. Okay, between sine and tangent there. So the cosine of 53, whoops, sorry, I keep bouncing that around there, and I'm going to get 0.6018. 0.6018 will equal 45 over K. I'm going to put that over 1. Now in this particular case here, when I cross multiply, I'm going to get K multiplied by 0.6018 is equal to 45 times 1. This is the situation here. When you don't know the hypotenuse, you're frequently going to have to do this. You're going to have to cross multiply, and then you're going to have to divide. So for me to get K here, I got to go 45 divided by 0.6018. Okay, cross multiply and divide. So I'm going to do 45 divided by that answer that I just came up with. I get 74.8. Now, and I'm reasonably happy that I did that right here, because I know that my hypotenuse should be the longest side in that triangle. And it is. Okay, it's much longer than the 45 that I was given, which is good. Now we're going to switch gears a little bit. We're going to still use trigonometry, but we're going to use it to find the angle instead. And there is a little bit of a trick here. And you got to make sure that you're using the calculator properly. Every time I was looking for a side, I was just using the sine, cos, tan button the way I see them on my calculator. Okay, now take a look here. I want to find angle G. That's the important angle to me. That's how I'm going to now label this triangle. This is the hypotenuse. Down here, this 12 is the opposite side, and this 5 is the adjacent. Now, I don't know what my hypotenuse is. Now, that's not to say I couldn't figure it out. I do have the Pythagorean theorem, so I could figure that out, but I don't need it. Okay, I know the opposite and I know the adjacent to G, which means I should be able to figure out what the tangent of G is. Okay, that's going to be 12 over 5. Remember what I said. The calculator knows how that ratio relates to the angle. So, but what you got to do is you got to tell the calculator that I don't want you to do the tangent of the angle. I want you to go backwards and get the angle from the tangent. And this is what you do. I'm going to get G, and just so that you understand this notation, what I'm doing here is I'm doing the inverse of the tangent function. Okay? So that this is like a little to the power of -1, just off the tangent there. Not over here, right above the trig ratio here. Now, your calculator has that too. And if I show you here, just above the tangent button is the tangent to the -1. That's what I want here. So to access that, I will go second tangent. So on my calculator, I'm getting this. And now I'm going to type in that ratio that I saw, 12 over 5. So this notation says that, hey, calculator, what you're going to get is the ratio. Can you tell me what angle goes with it? And I press enter. And to the nearest degree, I know that that angle is supposed to be 67. So G is equal to 67 degrees. So let's do this a couple more times here. So here I want to find angle. Now, this is angle A here. Really what that should say here, it should be clear here, because we typically use Greek letters for the angle here, and you can see there's a problem here. This is going to be angle alpha. Okay, let's just say angle alpha. Oh, these are in green, and those are hardly coming through. Let me write this out here. This is 8,100. This is 6,750. Basically just to illustrate that it doesn't matter how big these triangles are, it's still the same thing. So this is the angle that's important. This is the one that I'm going to use to label everything, which means this is my opposite side. The side that I'm given here, this is my adjacent, and the hypotenuse, like I said before, is always the hypotenuse. So I know the adjacent side and I know the hypotenuse. All I got to do is think what trig ratios put those together, and the answer is cosine. The cosine of alpha is going to equal the adjacent divided by the hypotenuse. For me to get the angle, I can't do cosine. The cosine button takes an angle and converts it into a ratio. I've got the ratio. So like we did before, if I want to figure out what the angle is, I have to do the inverse cosine. Okay. And so now I go to my calculator and I will press second cos, opens that up, and then I'm just going to type in that ratio there. So 6,750 divided by 8,100, 8,100. Whoa, you didn't even see it. I'm sorry. Didn't see that. Press enter, and I'm going to get to the nearest degree, 34 degrees. Okay, let's do one more. So I'm looking for angle A, so this is the angle that's important. Remember, the hypotenuse is still the hypotenuse, but that means this is going to be the adjacent. And right here, this is going to be the adjacent. Sorry, this is the opposite. I think I said adjacent when I said that. This is the opposite, this is the adjacent. Okay, and once again, this is going to end up being the cosine, because I have the adjacent and I have the hypotenuse. So this time the cosine of angle A will equal 5 over the hypotenuse 10. To get angle A, I have to use the calculator's inverse function, or second function there. So I'm going to just clear the calculator here. So I will go second cosine 5 divided by 10, and the answer is 60 degrees. And there you go, 60 degrees. So that's how those are the basic tools of trigonometry, and you'll be shocked. I mean, shocked at how much we can do with just those basic definitions. For the time being now, though, what I want to do with you is just walk through some word problems and show you how you might see some applications of it. Okay, so let's take a look at this problem. In Paris, Blair observes the Eiffel Tower from 100 feet away and measures her angle of elevation to the top of the tower, so measured from the horizontal up to the top of the tower, to be 84.6. How tall to the nearest foot is the Eiffel Tower? So what you want to figure out here is sorry, if you can see the diagram here, is the y. So here's the angle that's significant in this problem, and it's going to help me label the parts of the triangle here. I am looking for the opposite side, but I gave you the adjacent, the 100. Okay? I don't have any information about the hypotenuse. So I need a trig ratio that only works with the opposite and the adjacent. And the answer to that is it's got to be the tangent. So the tangent of that angle, 84.6 degrees, is going to equal the y value, and I don't know what that is, that's what I'm looking for, over 100, the adjacent side. So now, I go to my calculator. Okay, I'm going to just clear, whoops. I'm going to clear that all up there. The tangent of 84.6, that ratio is 10. You normally go to 4 decimal places with the trig ratio, so 10.5789. 10.5789 is equal to y over 100. And then, once I've got the ratio, I put it over 1. And again, I'm going to do the cross multiple here. Now, this time, though, I don't even need to use the calculator because when I multiply by 100, that's just going to move the decimal 2 places to the right. Yeah, it makes this one a little bit easier. So this is going to be 1057.89 feet is going to equal y. But we want this to the nearest foot. So we're going to round this, and we'll say that the tower is 1,058 feet tall. Okay? I hope that makes sense. Okay, let's do a couple more examples. Okay, so this question says that a ladder leans against the brick wall. The foot of the ladder is 6 feet away from the wall, and the ladder reaches a height of 15 feet on the wall. Find the angle the ladder makes with the wall. Okay, so here's the wall, and it usually helps to draw these things out here. And you can assume that the wall makes a 90-degree angle with the floor. I mean, if it doesn't, then the math gets a little bit more complicated, but then that's a terrible wall. So here you go. Here's our ladder. It's 6 feet away there, and it's 15 feet away there. We want to know the angle that the ladder makes with the wall. The ladder and the wall. Well, that's this angle up here. So let's put a theta right there. Now, it's important to figure that out because if you don't know where that angle is, then you don't know which of these is supposed to be considered the opposite and which is the adjacent. So in this case right here, I can see that the 6 feet is going to be my adjacent and the 15 feet is going to be my opposite. So I know, or at least I can come up with a ratio that uses the opposite and the adjacent. And I know that that is, once again, my tangent ratio. So the tangent of theta, this time I don't know the angle, but I do know that my sides are 6 and 15. Okay? So I know that what I'm going to do here to figure out what that angle is, I'm going to use the inverse tangent of 6 over 15. Because regular tangent takes an angle and produces the ratio. I know the ratio. I need to go backwards to the angle. So second tangent, and then 6 divided by 15, 21.8 or 22 degrees. Okay, so the ladder makes an angle of 22 degrees with the wall. Okay, our next one here says Grace and Ariane are standing apart on a straight road. Okay, they observe a hot air balloon directly between them, 1,400 feet above the road. Okay, the angle of elevation from Grace is 85, and the angle of elevation from Ariane is 81. Now, it's important to note that those are not the same angles. sometimes people, when they jump into this, they immediately assume those are the same when they make their drawing here, and it kind of throws off their math a little bit. We're going to draw a diagram to illustrate the situation here, and then we're going to find out the distance between Grace and Ariane. Okay, we got to draw this out here. So here's, right here, here's Grace, and here's Ariane. Now, Grace has the larger angle of elevation. So what I suspect is, and I'm going to kind of exaggerate this, we got this hot air balloon, and it's going to be a little bit closer to Grace here. So here's your hot air balloon. Woo! Whatever, you get the idea. And Grace is looking up at it, and this is 85 degrees. Ariane is also looking up at it, and this is 81 degrees. And again, I've chosen to, well, I didn't choose to do this, I was told to put those there. The angle of elevation is always from the horizontal up. Now, we know that the balloon is 1,432 feet up. And what we want to do is we want to figure out the distance between Grace and Ariane. Now, I've actually got two different right-angled triangles here. So this is actually what we would consider like a multi-triangle problem. I'm actually going to have to do two bits of work together and two bits of work and add these together. I am going to need to figure out the distance from Grace to the point right under the balloon in that right-angled triangle. And then I'm going to need to figure out the distance from Ariane to the point right underneath the balloon and look at just this triangle. And then I'll add them together. Now, let's focus on this triangle first. Here's the angle that I'm given. That's the thing that's important. So that means that what I'm given here is the opposite side, and what I'm looking for is the adjacent side. Now, you probably recognize already that, well, wait a minute, that's just a tan ratio. Isn't that what all of our word problems have been thus far? And yeah, it is tangent. It's going to be tangent a lot because in most applications, it's easiest to measure the opposite and adjacent sides of the triangle. Often the hypotenuse is just really awkward. Like if we were to write a problem here and I told you that Grace was a certain distance from the hot air balloon, you might pause and say, how on earth do they know that? Whereas it is fairly easy to figure out how high up the balloon is. Okay, and then even we could even measure that distance across there, but for right now we're assuming we don't know that. So for Grace, again, it's going to be the tangent, and this time my ratio is going to be 1,432 over my adjacent x. I don't know what that is. So I go to my calculator. I want to figure out what the tangent of 85 is. I got to figure out what that ratio is. And to 4 decimal places, that's going to be 11.4301. Okay, 11.4301. I'm going to put that over 1 so that I can cross multiply. But notice in this case that cross multiplication doesn't immediately deal with my problem. What I'm going to do here is I have to divide by the coefficient here. So I'm going to get 1432 divided by 11.4301. Now, what I'm going to do here, though, is I'm just going to use the value that's on my calculator. So I'm going to put in 1432 divided by the answer that I just created, this 11.43, but I'll let the calculator do that. And I get to the nearest tenth that's 125.3. Oh, I'm sorry, they want the answer to the nearest foot. So to the nearest foot, that would be 125 feet. Okay? Now let's take a quick look at Ariane. Again, I have the angle, and again, that's going to make this 1432 the opposite, and the y here the adjacent. So once again, I'm looking at the tangent ratio. That's going to be 1432 over, whoops, 2 over y. Now, you should see here that this is going to actually perfectly mirror what I just did. Okay. First, though, I'm going to go into my calculator. I'm going to take the tangent, whoops, of 81. So 6.3138 equal 1432 over y. Put that over 1. And we cross multiply. Whoops. And then we divide. So y is going to equal 1432 over 6.3138. But I'm going to use what's in the calculator, so I'm going to do 1432 divided by, whoops, sorry, delete that. I'm going to divide by the answer that I just came up with, and I'm going to get 226. Now, to the nearest foot though, 227. So y is equal to 227 feet. And now I can add those together to figure out the distance apart here. So therefore, x plus y is going to equal 125 plus 227. I'll just do this real quick so I don't do it wrong in my head here, because that would be a little embarrassing. And I'm going to get 352 feet. So Grace and Ariane are 352 feet apart. That's it. That's how you use trig. I hope that gives you a pretty good idea. I hope that gives you a little bit of confidence using trigonometry. It really is a lot of the same thing over and over again. Just want to make sure that you remember that when you're looking for the ratio, when you know what the angle is, then you're just going to use the regular sine, cos, and tan. But if you're looking for the angle, that's when you're going to use that second function, that inverse trig function.